about statistical analysis, the basic statistics about your dataset. For that, I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second dataset, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in Pandas library. I'll move to the top and I'll copy the file location and we'll change the name of the file. Copy this and let me paste it here, and instead of COVID_19_India, I'm going to say COVID_vaccine_statewise. Okay, so this is the dataset that we saw, COVID_vaccine_statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now, from the first data set, which is the COVID_df data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed, Indian national and confirmed, foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID_df dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths, and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID_df. I'll pass in my column name, that is date. I'll say equal to pd dot, I'll use the pandas function, that is to_datetime. I'll say COVID_df, which is my data frame name. Pass in my variable, which is date. Give a comma. and I'll use my argument, that is format equal to, I'll say %y, give a dash, say %m, give another dash and say %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID_df. Within square brackets, I'll give my new column, which is active_cases. I'll say equal to COVID_df, and my first column would be the confirmed cases column minus, I'll say COVID_df, then I'll pass in my cured column plus, I'll again say COVID_df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the Pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot_table function for this. I'll create a variable called statewise and say pd dot, I'll use the pivot_table function. I'll pass in my data frame, that is COVID_df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say statewise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets, I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured, I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say statewise equal to, I'll use the function sort underscore values. So I'll pass in my variable statewise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the Matplotlib library. So here you can see there's a nice documentation on choosing color maps in Matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now as I said in the beginning, there are a few discrepancies in the dataset. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated, and here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate, and we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra, and if I scroll down, the mortality rate is also high for Uttarakhand. If you see here, if I scroll further, you have Punjab, the mortality rate is also high. Alright, So this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay. So we are going to explore another very important Pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort underscore values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false, say dot, and then reset my index. For that I'll use reset underscore index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top underscore 10 underscore active underscore cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for Matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state slash union territory. Give another comma. We're going to pass in the line width to 2. I'll say line width equal to 2 and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state slash union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label, and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID_df, followed by using the group by function, and I want to group my data based on the state / union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm going to sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay. After that, I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple, I'll say 18, let's say 5. Now let's give a title. For that I'll use the title function, which is present in the Matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my Seaborn library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state / union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label. So I'll say plt dot x label. X label would be states. My y label will be total death cases. Then I'll write plt dot show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice, even in our data that we collected from Kaggle. Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results, or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh. with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as SNS dot. This time we are going to create a line plot. My data would be my original data frame, that is COVID_DF, and within square brackets I'll say COVID_DF, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function, so the states should include Maharashtra, I'll give a comma, the next state should be Karnataka, next we have Kerala, give another comma, my fourth state is Tamil Nadu, give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say x equal to the date column, y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and to make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_DF. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. You see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased luckily, Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the Pandas library to do it. So I'll say vaccine underscore df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine underscore date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine underscore date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine underscore date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types, and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine underscore df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step we are going to drop a few missing value columns. So I'll say a new variable called vaccination. I'll give the data frame name vaccine underscore df and use the drop function, and inside the drop function we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma The second column is AEFI. The next column is 18 to 44 years. Within bracket it has doses administered. Give a comma. I'll say 45 to 60 years. Doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop, and finally I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have EFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered, finally we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the Plotly library that we had imported, which is this one, Plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. We need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly, we'll filter out the female individuals. I'll say female equal to vaccination, which is my new data frame. Within square brackets, I'll pass in the column name female individual vaccinated. I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the Plotly library. I am going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it'll take some time to create the pie chart. Here we go. See, here I have my title, male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay, so to do that I'll say vaccine. I'm creating another variable called vaccine, and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay, now you can see here, if I scroll to the right and if I check, we have successfully renamed our column. Alright, now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state. Okay, for this I'll first create a variable called vax underscore VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column, and we'll find the total sum of vaccinated individuals for each state. I'll convert this to frame. There should be a dot to underscore frame, and I'll pass in my column name, which is total. After that I'll say max underscore VAC equal to max underscore VAC dot sort underscore values. I'm going to sort it by my total column. and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined, then I have the line width and the edge color as well. I've given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used 2 datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project we'll be using the Tableau software and a global coronavirus dataset. First we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first 2 datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are 2 columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate, this is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau Public. You can see here I have Tableau Public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau Public Edition. So here you can see I have created a few visuals already. If you want, you can clear them out. Okay. Now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under connect we have to a file. I'm going to use text file, and under Chrome downloads I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so first of all we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I'm going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data. As I told you, this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases within country and region. There you go. So here you can see these are the countries which have very few cases, and if I scroll down, you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again, you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay, now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases, so what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I click on undo, so Control Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly, you can sort it in ascending order. Here you have the option to sort your data. Okay, cool. And below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly, you can change it here as well. Top 10 confirmed countries. Okay, now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, And now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico, here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African Republic, there's Congo, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria. Now I'm going to drag the confirmed cases column onto label so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields, so it has removed my fields from rows and columns and put it under size, color and label. Next I will drag my country column and put it under filters, and from here I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. I'll keep it tab blue bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization where we'll see about the recoveries. So before we move on to create a visualization for the top 10 or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau select the automatic palette. If you want you can change it to different palettes. Let's say I'll go with gold purple diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one. Let's say red green white diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time instead of sum we are going to choose average. Okay, and here I'll select my packed bubble chart. After that I am going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. So click on apply and OK. You can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that I am going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay, so by default the shape is a circle, and to see all the countries I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and on the top you have US with the highest number of confirmed cases and the highest number of deaths as per our dataset. Then you also have Brazil here, which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that I'll drag my country column onto filters, and I'll go to top, I'll filter by field, I'll say top 10 and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. OK. Now if you see, we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active, I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay. So first I'll drag mortality rate onto column, and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Finally, we'll move ahead to our last visualization, where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column, and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the death cases. Let me show you how to do it. So I'll drag my country field onto columns, and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column. I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the axis values. You can synchronize the axis values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to short it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want. And to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530k. To do that, what I'll do is I'll go to format, and here we have the option to select font, and in font I'll go to fields and click on sum of deaths, and here in this pane I'll choose number custom, decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531k, 193k, 158k, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on new dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that. Now you are getting some messages here: 2 unknown, 4 nulls. You can remove them as well, and here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this, and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly, there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. We have the region names, so AFG is for Afghanistan, you have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male, or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I have opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete_events.csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read_CSV. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events. The second one is noc_regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes.head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions.head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the Pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes_df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes_df.head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes_events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes_df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows, so 2,71,116 rows, and earlier we had 15 columns in the first dataset, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes_df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region. I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. My second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N. The rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes_df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and notes. All right. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile and the 75th percentile value of the columns ID, age, height, weight and year. Alright. Now one thing to notice here is if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any nan or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9,474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to, I'll use my data frame, that is athletes underscore df. I'll say dot team, then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896, you have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this PLT_x means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the x and the y-axis. So my x-axis has top. I should make this top 10 countries because above we used top_10_ countries. Similarly for y-axis, I'll make it top_10_ countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the Matplotlib library specifically for this visualization. So I'll say plt.figure will give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the x labels. I'll say plt dot x label. This will have age. Then we'll say plt dot y label, and this will have the label as number of participants. Next, I'm going to use the hist function. So I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function. So np is for NumPy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color. This is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the Summer and Winter Olympic Games. Let's look at the different sporting events that are part of the Summer and Winter Olympic Games. Just to give you a heads up, the Winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the Winter Olympics. Now similarly, let's see for Summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer. Dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the Summer Olympics compared to Winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the Matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts dot index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now we can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we're going to find the total number of medals that the athletes have won. So I'll use my data frame athletes_df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes_df. Using square brackets, I'll say athletes_df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the Pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright. Now here, this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female, and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I have given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says women participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis. Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say, 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it. And if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years. And since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright. Now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy, and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6, so it will give me the top 6 countries. Alright, now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and we'll display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20 and Japan 17. Alright. Now using the above result we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values. So we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis, I'll say athletes underscore df. This time we'll consider the weight column. Again I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Thank you all for watching this video on Python data analysis projects for 2022. I hope it was useful and informative. Thanks again, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.